Good morning, everyone. So today we're going to study related rates on basic calculus. So let us first define what is related rates. So related rates in calculus involve analyzing how the rates of change different quantities are connected when they're tied together by an equation or a geometric relationship. Essentially, it's about figuring out how the speed of which one thing is changing affects the speed of which another thing is changing. For example, if you're inflating a balloon, related rates would help you understand how the balloon's volume is changing over time based on how quickly you're blowing air into it. So basically, related rates is a calculus topic that deals with the rates of change of related quantities. It involves finding how the rates of change of different variables are related to each other when they are dependent on each other throughout the equation or geometric relationship. So basically, it means that it is the study of the rates of change of related quantities. Like in the example I've given you in the balloon, volume is changing over the time based on how quickly you're blowing air. So I'm gonna pass it on to JL to teach you more about related rates by solving world problem examples. So you can know how to apply these in real life situations. And thank you, and I'm gonna pass it on to JL.
First, we start with the formula for the volume of cylinder, which is V equals pi r squared h. Given that our tank has a radius of 4 meters and water is filling it at a rate of 2 cubic per meters per minute. Next, we differentiate the volume equation with respect to time to find the rate of change of height, dh over dt. This gives us dv over dt equals pi r squared dh over dt. Now let's plug in the values and solve for dh over dt. dv over dt equals pi r squared dh over dt. Then 2 equals pi 4 squared dh over dt. Substituting the values, we get 2 equals 16 pi dh over dt, which simplifies to dh over dt equals 2 over 16 pi. Simplifying it will give us the answer, which is dh over dt equals 1 over 8 pi. So the water level in a cylindrical tank is rising at a rate of 1 over 8 pi. A conical tank with a height of 10 meters and a radius of 5 meters is being filled with water at a rate of 3 cubic meters per minute. At what rate is the water level rising when the water is 6 meters deep? First, let's consider a cylindrical tank with a radius of 4 meters being filled at a rate of 2 cubic meters per minute. Using the formula V equals pi r squared h, we differentiate with respect to time to find dh over dt. After solving, we find that the water level rises at a rate of 1 over 8 pi meters per minute. Now let's move on to a conical tank with a height of 10 meters, radius of 5 meters, and water filling it at 3 cubic meters per minute. Differentiating the volume formula, V equals 1/3 pi r squared h with respect to time gives us dv over dt equals 1/3 pi r squared dh over dt. Solving for dh over dt, we find that when the water is 6 meters deep, the water level rises at a rate of 9 over 25 pi meters per minute.
So we are given that ds over dt is equals to 2 inches per minute, and the other is ds over dt is equals to 1 inch per minute. So we want to find uh, dA over dt when each sides is 6 inches long. And we know that A is equals to S squared, and differentiate with sides with respect to time. So we're gonna substitute it. dA over dt is equals to d over dt and S squared. Using chain rule, dA over dt is equals to 2s ds over dt. So now we plug in the given values. At s equals 6, we know that ds over dt is equals to 2. So dA over dt is equals to 2, 6, and 2. dA over dt is equal to 24. We are given that dx over dt is equal to 30 mph car A speed, and the other is dy over dt is equals to 40 mph car B speed. So we want to find the dz over dt when x is equals to 3 over 4 mile. So we can use the Pythagorean theorem to relate x, y, and z. So we'll be having z squared equals to 1 over x, 1 minus x squared plus 2 minus y squared, and differentiate both sides of the equation with respect to time. So d over dt z squared equals d over dt 1 minus x squared plus 2 minus y squared. Using chain rule, 2z is equals 2z over dz over d2 is equals to 1 minus x dx over dt plus 2 minus 4 and dy over dt. Now we can plug in the given values and the none of chains of x to solve for dz over dt when x is equals to 3 over 4. And at x is equals to 3 over 4, we know that y is equals to negative 3 over 4 and equals to 5 over 4. And x equals 3 over 4, and we know that y is equals to negative 3 over 4 equals to 5 over 4. So unplug these values into the equation. So we'll be having 2z and dc over dt is equal to 2 1 3 over 4 and 30 plus 2 open 2 minus 5 over 4 open and 40 close. Next is 2z dz is equals to 2 1 over 4 30 plus 2 3 over 4 and 40. Next is 80 dz dt is equals to 2 7.5 minus 2 over 30 so open 30 close. So 2z is equal to dz d2 equals 15 minus 60. So 2z plus 2z dz over dt is equals to negative 45. Last one is dz over dt is equals to negative 45 over 2z. So now we need to find z when x is equals to 3 over 4 mile. Next is z squared is equals to 1 minus 3 over 4 squared plus 2 minus 5 over 4 squared. Next is c squared equals 1 over 4 squared plus 3 over 4 squared. Next is z2 equals 1 over 16 plus 9 over 16 and z2 is equals to 10 over 16. Yes. Next is z squared is equals to 5 over 8. The last one is z squared is equals to 5 over 8 and equals 5 over 2 root 2. So yan. Now we now we plug 2 equals root 5 over 2 root 2 into dz over dt. Plug z is equals to root 5 over 2 root 2 into dz over dt. We're having dz over dt equals negative 45 over 2 root 5 over 2 root 2. Next is dz over dt equals negative 45 2 root 2 over root 5. Next is d over dt equals negative 90 and root 2 over root 5. And next is dz over dt equals negative 90 root 10 over 5. Next is dz over dt is equals negative 18 root 10 over 5. So when car A is 3/4 mile from the intersection, the distance between the two cars is changing at a rule of negative 18 root 10 over 5 mph.